This week, Lab TV travels to an Air Force research lab in Dayton, Ohio, to meet a scientist who does detective work using a cool technique called chromatography.
Chromatography is when you have an unknown solution and you can't tell what's in it at all. It all looks the same way. Kind of like a chocolate ice cream cone, you know that it's made up of all different kind of components. You know, there's milk, eggs, sugar, chocolate in there, but you can't tell what's in it just by looking at the cone.
Using chromatography, scientists can separate out all the components in a mixture and then identify each one.
Chromatography means color writing. Dye makers use this technique to separate the different dye pigments in their colors. This color, red, this maroon color, is actually made up of maybe 10 different separate colors, and chromatography pulls them apart.
Here, Milissa shows the principles of chromatography using water-soluble markers. A drop of water causes the dyes in each marker to flow out and separate on the coffee filters.
I'm going to pick the first one up. This is the black marker. You can see the compound traveling, and it is made up of blue dye and maybe some purple dye or red. This blue one, you can tell, is mainly just blue. And this was the purple one, purple marker, and you can see the reds and then the blues separated out.
Chromatography instruments, or chromatographs, can also be used in crime labs to separate chemicals like drugs or to find pollution in water and air samples. Milissa and her team use it to analyze the different components in jet fuel.
Fuel is made up of hundreds of different compounds. Most of them are hydrocarbon chains. So they are carbons with hydrogens off the sides of them, and they're chains of 2 carbons, 3 carbons, 4 carbons, and they come in different patterns too.
Jet fuels need to be a precise blend of hydrocarbons. Milissa and her team use gas chromatography to analyze their fuels.
They call it a gas chromatograph because the solution that you're analyzing with all the different compounds is in the gas phase.
They inject the sample into the machine. In the first phase, the mobile phase, an inert gas like helium sweeps the mixture down a long tube called the column.
So when the compound goes through the column, the separate compounds that are more attracted to the coating stick on that stationary phase for a longer amount of time, while the compounds that are not as attracted to the coating continue down, and that's how they get separated.
Each individual component leaves the tube at a different time, and that creates a peak on the printout.
We get a computer readout, and it looks like your basic graph. You have the X and Y axis, and then you have kind of lines that go up and down, and it shows you there's a peak, so there was your first compound, the second peak, your second compound, and so on.
Using these results, Milissa and her team can help develop more efficient fuels for the Air Force.
I like it because you can take something you have no clue what's in it at all. You have the solution, it looks clear, it looks just like it's water basically, and you can put it in this box and out pops these results that tell you exactly what's in it. It's really cool. I like what I do because I can see where my research goes. I can look up in the sky, you see a jet plane, and you know that some of what you did for your research is what is on that plane.
To find out more about research chemistry and chromatography, check out labtvonline.org.